Hello, good evening. I'm Miss Gunn from Chemistry Unit. Welcome to O2H program, Semester 1, Session 2022-2023. Today, our discussion is on Chapter 5, States of Matter. There are four topics in this chapter, namely gas, liquid, solid, and phase diagram. We are going to discuss 4 questions which cover these subtopics. Without further ado, let's start with question 1. A 10-liter container consists of 4 grams of hydrogen gas and 28 gram nitrogen gas. If the temperature is 31 degrees Celsius, determine the total pressure of the gas mixture. Alright, we need to use Dalton's law because this involves a mixture of 2 different gases. In order to calculate the total pressure, we need to apply the ideal gas equation. From PV equals to nRT, we can obtain the total pressure by using this formula. P total equals to N total RT over V. Okay. To get the N total, we need to calculate the mole of hydrogen gas and mole of nitrogen gas. Okay. The number of mole of hydrogen gas is 2 mole and the number of mole of nitrogen gas is 1 mole. So the total number of mole is 2 plus 1, which is equal to 3. Substitute the 3 moles into the formula, we're able to get 7.48 atmosphere. Okay, the allocation of mark is the first mark goes to formula PV equals nRT. The second mark will go to the N total, 3 mole, which is 3 mole. The third mark will go to the final answer with unit. Okay, so the first mark is either the formula or the insertion. Okay, you can also write the P total as PT. Okay, P total, PT. So all these 3 will be able to get 1 mark. Okay, let's proceed to second part. Calculate the partial pressure of the hydrogen gas. Since we have already got the total pressure, we can use the mole fraction of hydrogen gas to obtain the partial pressure. P hydrogen, partial pressure of hydrogen, is mole fraction of hydrogen multiplied by total pressure. Mole fraction is number of mole of nitrogen gas over total number of mole, which is 2 over 3. The final answer of partial pressure of hydrogen gas will be 4.99 atmosphere. The first mark will go to our formula or insertion. The second mark will go to the final answer with unit. Final answer with unit. Okay. Alternatively, we can also obtain the total pressure and partial pressure this way. Some students, they might calculate the partial pressure of the hydrogen gas first. Yeah, that means they might calculate the second part first. Then only they total up the partial pressure. Okay, using the same method, they are able to calculate the partial pressure of nitrogen gas, which involve 1 mole of the gas multiplied by the gas constant and temperature 204. 204 is 31 plus 273. All the units for all the other variables must comply with the the unit for the gas constant, which is liter atm per mole per Kelvin. That means the temperature must be in Kelvin, the pressure must be in atmosphere. Okay, so when we total up the partial pressure of hydrogen gas and nitrogen gas, we'll be able to get P total as well. Okay, that means second part and first part can be solved this way. The allocation of mark is the same. Yeah, we get 5 marks. 1, 2, 3, 4, 5. 5 marks for the first part and the second part. Yeah, you have to label clearly if you start with second part first. Okay, let's proceed to the next part. What will happen if the gaseous mixture is heated to 550 degrees Celsius? When it's heated to 500 degrees Celsius, that means the gas molecules or gas particles will gain kinetic energy. Okay, so when the gas mixture is heated, the kinetic energy of the gas increases. Okay, imagine this is the container. If you heat up, okay, there are two type of gas. When you heat up, they will gain the kinetic energy and they will therefore collide with the wall of container more frequently. Or you can also say that frequency of collision between particles and wall of container increases. Frequency of collision is referring to the number of collision per second. Collision per second. Yeah, so frequency of collision between particles and wall of container increases, or the molecules will collide with the wall of container more frequently. Therefore, the pressure of the mixture will increase. Okay, so there are 2 marks allocated for the answers. The first mark will go to kinetic energy increases. The second mark will be the frequency of collision between particles and wall of container increases and pressure increases. Okay, so total mark is 7 marks for first part. Okay, as for part B, under the same condition of temperature and density, determine which gas behave less ideally. To behave as ideal gas, the intermolecular attractive forces should be negligible, and also the volume of the gas molecules must be negligible in order to behave ideally, because these are the behavior of ideal gas. Okay, as for methane gas and sulfur dioxide gas, okay, the molar mass or the relative molecular mass is 12 plus 4, okay, is 16, whereas for the sulfur dioxide, the relative molecular mass is 32.1 plus 16.0 times 2, which is 64.1. Okay, so we can see that the sulfur dioxide molecules is much more bigger than the methane molecule. Okay, so of course the sulfur dioxide will behave less ideally, because it will deviate more from the behavior of ideal gas. Okay, so the answer will be sulfur dioxide gas behave less ideally compared to methane gas. Okay, the reason: size of sulfur dioxide is bigger than methane, or you can also say that volume of sulfur dioxide is bigger than the methane molecules, or volume of sulfur dioxide is more significant compared to volume of methane, because these are all related to the molecular size. Yeah. Okay. Intermolecular forces between sulfur dioxide gases are stronger than methane, yeah, than that between methane molecules. Okay, this is because van der Waals forces increases with molecular size. Yeah, sulfur dioxide has bigger molecular size, therefore it exhibit stronger van der Waals forces between the molecules. Okay, the allocation of mark are as shown on the screen. Yeah, they are together 3 marks. Okay, next. Okay, this is about liquid. In an experiment where gelatin was added to water, the water became viscous. Explain the relationship between viscosity and intermolecular forces. Viscous is likat. In BM, it's called likat, kelikatan. Yeah. Viscosity is the resistance of liquid or fluid to flow. Okay. When viscosity increases, that means the liquid is more difficult to flow. Okay, when we want to discuss the relationship between the viscosity and intermolecular forces, we should compare the difficulty of the liquid to flow. Okay, of course, the stronger the intermolecular forces, the harder for the liquid to flow. Therefore, we say that the greater the viscosity of the liquid. Okay, so you can gain these 2 marks for these 2 answers. Okay, then we proceed to our second questions. Okay, the total mark of question 1 is 12 marks. Okay, remember to jot down the mark. Okay, at the end of the discussion, you may add up all the total marks and see what you get. This is how you evaluate yourself. Okay, in question number 2, part A, the question is about the Dalton's law. Yeah, what we can see here is a sample of zinc metal reacts completely with an excess hydrochloric acid. The reaction occurs through this. This is a balance equation for the reaction that takes place. The hydrogen gas is collected over water. That means water displacement method. The volume of the gas collected is 7.80 liter and its pressure is 0.980 0 atmosphere. Calculate the amount of zinc metal in gram consumed in the reaction. Water vapor pressure given is 23.8 millimeter mercury at 25 degrees Celsius. All right, so this is a diagram. This is a diagram. When the gas is collected over the water, that means the pressure inside the vessel is not only the gas itself. It's the mixture of gas. Mixture of gas, that means it involves the hydrogen gas as well as the water vapor. Water vapor, H2O. Yeah, water vapor. Okay, so the P total given here 0.980 atmosphere. Yeah, it's not. This is the P total. It's not mainly. Yeah, it's not merely for the hydrogen gas. It involves the partial pressure of the water vapor as well. Okay, so to get our partial pressure of hydrogen gas, we need to subtract the partial pressure of water vapor from the total pressure given. So the partial pressure of the water vapor is 23.8 millimeter mercury. We need to convert it into atmosphere. Okay, 23.8 millimeter mercury divide 23.8 millimeter divide by 760 millimeter mercury will be 0.0313 atmosphere. Okay, if you are not sure whether you need to multiply or divide, you can do this way. Yeah, because when you do this way, see millimeter. Yeah, of course, the 760 must be placed below. Okay, so yeah, so the partial pressure of the hydrogen gas will be 0.980 atmosphere minus 0.0313 atmosphere. So we get 0.949 atmosphere. Okay, we need to relate the number of mole of hydrogen gas with the number of mole of zinc consumed or used up. Okay, because the PV equationality can only apply if it is gas. Okay, we can calculate the number of mole of hydrogen gas using this P partial pressure of hydrogen, volume of the gas. Volume of the gas is the volume of the container or volume of the flask. Okay, over RT. Yeah, we calculate this. Then using stoichiometry, we can calculate the number of mole of zinc used up in this reaction. Okay, the allocation of mark for this part is only 1 mark for partial pressure of hydrogen gas. Okay, this is the balanced equation. Nitrogen gas, the number of mole obtained here, after we insert the data into the formula, we will be able to get 0.3027 mole. Yeah, remember all the units for other variables must comply with the unit of gas constant, R. Okay, so formula and insertion, you will be able to get 1 mark if correct. The final answer, 1 mark, will be given to the number of mole of hydrogen gas. Okay, then using stoichiometry, from chemical equation, 1 mole of hydrogen gas equivalent to 1 mole of zinc. So 0.3027 mole of hydrogen gas the number of mole of zinc is 0.3027. Yeah, same number of mole. Okay, although the number of mole is the same, but you need to show, because yeah, marks are given for the stoichiometry calculation. So mass of zinc consumed is 0.3027 mole times molar mass, which is 19.8 gram. Okay, so this is 1 mark. Okay, remember, if you write like this, if you straight away put zinc, number of mole of zinc equals to partial pressure, like this, yeah, you definitely wrong. This is wrong method. Yeah, because PV equationality only meant for gas. Okay, so you need to show this part. This part. All right. Okay, so let's proceed to second part. Okay, this is a phase diagram. All the line or curve are positive. Yeah, positive slope. So this is a phase diagram. This is actually the phase diagram from carbon dioxide. Okay, we can easily separate this one into solid. This is liquid phase. This is gas phase. Okay, the question is like this. Name the process that occur as carbon dioxide undergoes, that occurs as carbon dioxide undergoes a phase change from Roman 1 to Roman 2. Okay, Roman 1, Roman 2, this is the point. This is the point. So if it is, you see, at constant pressure, when we increase the temperature, what will happen is we can see that the solid will change to liquid. Okay, the process that solid change to liquid is called what? Melting. Yeah, it's called melting. It's a melting process. Name the process. So we just name it only. We do not have to explain how the process occurs. Yeah, we just say melting process. Melting process. Okay. Next, state the physical state of carbon dioxide at A and B. Okay, point A is exactly on the line that separate the solid and liquid. Okay, and B, point B is the temperature and pressure that exactly located on the curve that separate liquid and gas. Okay, so therefore, there are two phases for each point. Yeah, there are two phases, but they exist in equilibrium. As for point A, at A, solid and liquid exist in equilibrium. As for point B, liquid and gas exist in equilibrium. Okay, all right, so next we will see this. Explain the formation of carbon dioxide, solid carbon dioxide, which is dry ice, at room condition. Room condition is room temperature and pressure, which involve 1 atmosphere and 25 degrees Celsius. So 25 degrees Celsius is somewhere here. Yeah, 1 atmosphere is also somewhere here. So you see, this is the, right, so this is the point here, where we have the room condition. Okay. The explanation is like this. constant pressure, it is impossible to form solid carbon dioxide at room temp condition because the triple temperature is below room temperature and the triple pressure is above room pressure. So at room condition, it will the solid carbon dioxide it will sublime into gas. It won't exist in the form of solid. Okay, so this one mark, and the other mark goes to the second part. Impossible to form solid. At room condition, there's no way for the solid carbon dioxide to retain as solid carbon dioxide. It will sublime. Yeah. This is because the room condition at room temperature and pressure, the temperature is higher than the triple point, where the pressure is lower than the triple point. Okay, so the total mark for this question 2 is 10 marks. All right, part 3. Describe Charles' law from the kinetic perspective. That means we need to explain by using the kinetic molecular theory. Okay, so there are two parts for this question. The first part is the description of Charles' law, and the second part is the calculation. For the first part, describe Charles' law from the kinetic perspective. Okay, we imagine this way. If the molecule, according to Charles' law, the volume of a fixed amount of gas is directly proportional to its absolute temperature at constant pressure. At constant pressure. Okay. So if we want to explain in terms of the kinetic molecular theory, we have to relate why volume is directly proportional to temperature. Okay, when we have constant number of mole and pressure. Okay, so the explanation will be this way. As the temperature increases, gas molecules move faster and therefore they collide more frequently with each other and also with the wall of container. Okay, since the pressure is constant, so the volume of the gas must increase in order to make the pressure constant. Okay, volume of the gas must be increased in order for the pressure to be constant. If not, the pressure will increase because when our previous question, okay, we have already discussed that when the molecules collide with the wall of container more frequently, the pressure will increase. Right? So in this case, if we want to have constant pressure, so the volume must increase. Okay, so this is Charles' law. Okay. You could also imagine by using the diagram like this. Right, so imagine when it gain energy, it will collide with a lot of containers. So of course the pressure inside will increase. So in order to make the pressure constant, the volume must be increased in order to have the same pressure. All right, so you must imagine this is a piston where this one can be adjust. The volume of the container is adjustable. Okay, the allocation of mark will be 1 mark for the statement of Charles' law, and another 2 mark is for the explanation. So all together, this question, 3 marks. Okay, we then look at the calculation part. The piston, a cylinder piston in BM is called on bore. All right, a piston cylinder holds 7 grams of carbon dioxide at 160 degrees Celsius and 110 kilopascal. Kilopascal is kilonewton meter, per meter squared. 1 atmosphere is equal to 101.325 kilopascal. Okay, how many grams of carbon dioxide will it hold at 27 degrees Celsius under the same pressure? Okay. Okay, if you look at the question, that means will it hold? That means the volume with the same volume. How many gram of carbon dioxide? And need to be used in order for it to have the same volume and same pressure as well. Okay, so what we can calculate here is, okay, we look at this 160 degrees Celsius and 110 kilopascal as well as 7 gram. Okay, we use this to calculate the volume, the volume of the carbon dioxide. Okay, using P equals nRT, ideal gas equation, the number of mole is mass over molar mass. Mass over molar mass. Okay, so we can manipulate the ideal gas equation in order to get the volume. The volume will be the M, mass over molar mass, times RT over P. Okay, so when we substitute the value of mass, molar mass, okay, molar mass of carbon dioxide, molar mass of carbon dioxide is 12 plus 16 multiplied by 2, which is 44 gram per mole. 44 gram per mole. Okay, as for the pressure, okay, 110 kilopascal, you need to convert it into atmosphere. Need to convert to atmosphere. Okay, you can do separately. Okay, that means you can do like this: partial pressure. Okay, 110 kilopascal. To change to ATM, we can use like this. We need to cancel this. So 1 ATM equals to 101.325 kilopascal. Kilopascal. So you may calculate, then only you substitute into it. It will be better. Instead of just inserting all the values into the formula. Okay, so the volume obtained will be 5.207 liter. Okay, 5.207 liter. Okay, so the mark allocation is like this. Okay, the first mark here will go to either PV equals nRT or PV equals to M over M RT or already put the V as the title of the formula. So either one will be able to get 1 mark. Okay, so the second mark will go to the final answer with volume. Okay, at 27 degrees Celsius under the same pressure, okay, we can use the same formula to calculate the mass. Okay, but at 27 degrees Celsius, the temperature will be different. Okay, it will be 27 plus 273 Kelvin. Yes. Okay, with the same volume, same pressure. Okay, same pressure, same volume, and molar mass the same. Okay, only the temperature is different. So you may insert into it this formula to calculate. So you get 10.10 gram. Yeah. So the mark will goes to 10.10 gram. Okay, in this case, formula will not be given marks, and because it's the same as this, yeah. So it won't be given any marks. So the final mark will goes to the final answer with unit. Okay, now we are going to question 3 part B. When a solid is heated in a closed container, it undergoes phase changes. Describe the process. Describe, yeah. The phase changes, of course, is from solid to liquid. Yeah, it's from solid to liquid. Solid change to liquid. This process involves melting process. Okay, if you are asked to describe the process, that means you have to relate to the kinetic energy and the molecular motion. The motion. All right, so imagine it when it is heated, solid is heated, the particles will gain more energy because solid, the particles are all very close to each other. They are arranged closely to each other. Okay, they only vibrate at fixed position, but once they get their energy, they gain energy, they will be able to overcome the intermolecular forces, so they are able to move more freely. Okay, so when a solid is heated in a closed container, its particles gain energy, hence vibrate more rapidly and energetically. Okay, you may also say the kinetic energy of the molecules increases. Okay, gain energy first. Second mark will be the vibrate more rapidly and energetically. As temperature approaches its melting point, the particles have enough energy to overcome the attractive forces between them. Therefore, particles are no longer held to their fixed position, and they are able to move more freely. Thus, solid is changing into liquid. Okay. So no longer held to their fixed position, 1 mark. Solids is changing into liquid, 1 mark. Okay, so altogether there are 5 points. Yeah, you need to put in 5 points because this question allocate 5 marks. So you must have at least 5 points to put in. Okay, total marks of this question number 3 is 11 marks. Okay, now we are coming to our last questions. Using copper, diamond, sulfur, and sodium chloride to represent various crystalline solids, identify the types of interparticle bonding that forms the state of the matter. Okay, to identify the type of interparticle bondings, we must know what is the structure, what is the type of crystalline solid for each of these. As for copper, uh, is metallic solid. Diamond is giant covalent solid. Sulfur is molecular covalent solid. And lastly, sodium chloride is ionic solid. Okay, ionic solid. So to explain this, we need to identify what type of crystalline solid first. Yeah. All right. So in copper, okay. Oh, I have given you the wrong diagram here. So copper, it should be copper. Copper. Okay, this is the diagram here of electron C model of copper ion. Okay, in copper, the metallic bonds formed between the copper ion, the positively charged copper ions, and its C of delocalized valence electron. This is a C of delocalized valence electron, yeah, which is negatively charged. Okay, so each mark, yeah, metallic bond 1 mark, and the explanation of how the bonds form 1 mark. Yeah, it formed between the positively charged metallic ion, which is the copper ion, and the C of delocalized valence electron, which is negative charge. Okay, in diamond has giant covalent solid. So in diamond, the strong covalent bond between the carbon atoms are forming a giant covalent solid. Yeah, this is the strong covalent bond. This one is the strong covalent bond. Okay, it's a giant covalent network. Okay, not limited to the atoms that show on this diagram. Yeah, actually, it has infinite number of carbon atom bonded together. Yeah, these are the carbon atom. Yeah, infinite. Okay, so many. Yeah, until we cannot count. All right, so this one also 2 marks. Yeah, 1 mark for the strong covalent bond and 1 mark for the giant covalent solid. Yeah. Okay. As for sulfur and sodium chloride, in sulfur, the van der Waals forces between the S8 molecules are forming molecular covalent solid or simple covalent solid. Okay, the 1 mark will go to the bonding and 1 mark is for the structure, the molecular covalent solid. Okay, this diagram shows the molecules. Yeah, the S8 molecule. Sulfur are made up of 8 sulfur atoms bonded together. Between the atoms, we have covalent bond. Between the molecules, we have van der Waals forces. As sulfur is non-polar molecule. So the van der Waals forces here is actually dispersion forces or London forces. Okay. And the last one, in sodium chloride, the ionic bonds are formed between the sodium ion and the chloride ion. Okay, you can imagine it this way. Okay, class. In exam, you need to identify the type of solid and also the type of bonding, the interparticle bonding. It's not necessary to give the diagrams. The diagrams given here is to explain clearer. Okay, in exam, you need to put it into words. You don't give diagrams only. If you give diagram, you must give explanation as well. Okay. For this question, the marks are only allocated for the explanation, the sentence or the sentences, not the diagram. But in actual exam, if you are unable to describe by giving the sentence, if you draw structure, you might be given mark as well. So don't leave the don't leave the answer blank like that. You must try to write and then draw something. Okay, so I repeat. So in this instance, first you need to identify type of solid. So we have metallic solid, giant covalent solid, molecular covalent solid, and ionic solid. So for each type of this solid, you need to explain the type of bonding. For metallic solid, you must mention the metallic form between the copper ion and the C of delocalized valence electron. As for the diamond, you must mention is the strong. The atoms are held by the strong covalent bond. Okay, you must also mention the type of solid, which is giant covalent solid. Okay, for sulfur, you need to mention it involves the molecular covalent solid, and in between the molecules we have van der Waals forces. Spelling of the van der Waals forces, you must make sure small v for van, okay, small letter d, and for van der Waals, you must use capital W. Okay, and for sodium chloride, you must mention it is ionic solid, or it involves the ions, sodium ion and chloride ion, and there are ionic bonds formed between the sodium ion and chloride ion. Okay, so we have already covered the 4 questions. Okay, I hope our discussion today will enhance your understanding for this chapter 4. Okay. All right. If you still cannot understand, please refer to your tutorial lecturer. Okay. With that, I will end this session. Thank you.